So this foldable, you want to turn it to the side that has most of the words on it, okay? We're going to be working on something called transformations for the next couple weeks, okay? So a transformation is when a figure is moved, yeah, we know. When a figure is moved,
oh my god.
So a transformation is basically moving something, okay? A congruence transformation, okay? Congruence transformation is something that changes the position of a figure, but not its size or shape. Okay, it changes the position of a figure, but not its size or shape. Okay, so there are some examples here. Okay, a congruence transformation, because congruence means it's the same. Okay, so the same size and the same shape. So that means no triangles are going to become rectangles, and no squares are going to become circles, that kind of thing. Okay, also the size is not going to change. Okay, there are some types of movement that will change the size. There are 3 of them that we're going to look at first that do not change the size. Okay, so the types that do not change the size are called translation, reflection, and rotation. We will get to one that does change the size later, but right now we're just looking at translation, reflection, and rotation. Okay, so those are the ones that do not change the size or shape. Those are called congruence transformations. So things are going to move, but they're not going to change the size or shape. So the first thing we're going to look at is something called a translation. Okay, a translation is basically when you slide a figure. Okay, so a translation is slide a figure.
Excuse me, can you sit down, please?
So a translation is a slide of a figure. Okay, there's something called coordinate notation for a translation. Okay, and coordinate notation for a translation is x comma y will become x plus a comma y plus b. So coordinate notation is basically when the a part on an x-axis, okay, when you're graphing a point, does the x part tell you the side to side or the up and down? If you're going to plot a point, does the x part, right. So this tells you side to side movement. That's the side to side. The y portion will tell you how something is going to move up or down. And you'll see, hopefully this will make a little bit better sense once we put numbers in here. Okay, so the a portion is the side to side movement. The y plus b portion is the up or down movement. So first thing I want to do is plot these points. Okay, so it says triangle ABC has vertices. Vertices are basically corners. At A is over 1, up 5. Remember, the first number always tells you side to side. So over 1, up 5. So count over 1 and up. 1, 2, 3, 4, 5. That's point A. And I want you to label it as well. That's point A. Then I also want you to plot point B. So that's 5, 5. So right 5, up 5. 1, 2, 3, 4, 5, up 5. So right 5, up 5. And vertice C is at over 4, up 3. So remember, our the x portion always tells you side to side. The y portion tells you up and down. Then once you have these 3 corners plotted, you can connect them with lines.
It makes a triangle.
It does make a triangle, yes. Now, it says sketch triangle ABC and its image after a translation of x minus 4, y minus 3. So basically what we're doing here is this tells you for each x spot, you're going to move it -4. So we already said that X movement is side to side. Do you think this negative means you're going to move left or right? Left. Okay, so this tells you that each X part, you're going to move left 4. And do you think the Y portion, -3, tells you to move up or down?
Down.
Down, right. Okay, so the way that we do this is literally from each point, you're going to move left 4, down 3. So start at A, and we're going to move left 4 from here, and you're just going to count the numbers, or count each spot. So left 4, so over 1, 2, 3, 4, and down 1, 2, 3. That is your new A location. Now, to show that it's a different A location, you write it as A and what's called prime. Okay, so it's A like an exponent of 1. That's called A prime. Then we're going to do the same thing for B. From B, we're going to move left 4, down 3. So count over 1, 2, 3, 4, down 1, 2, 3. Sorry, I ran out this morning. And that is B prime. Okay, so that's your new B location. Then you're going to do the same thing for C. Move left 4, down 3. And that's your new C prime location. Once you have all your new locations, connect the dots to make a triangle.
Oop.
You're moving left 4, down 3 for each one of them. So if I was going to show it, what would be my old XY locations and how do they move to my new XY locations? So my old A location was 1, 5. Where is my new A location? What coordinate is that? If I was going to label what coordinate this is.
That's A prime.
I know that's A prime, but tell me the numbers. Like if I asked what numbers these are on. Tell me what point that is with the numbers, with the XY coordinate numbers. -1, 2, 3, up 2. So this moves to be -3, 2. So if you look at this, is this right? Did the X number go down 4?
Yeah.
1 minus 4 gives you -3. Did the Y number go down 3? 5 to 2. Okay, so you could figure these out without drawing them. It's easier though if you draw them. The B location was at 5, 5. What is my new B location? What point is B at? My B prime. What point is this?
B prime.
What coordinate location is this at?
2, 1.
Over 1, up 2. So we always go side to side first. So 1, 2. And this also worked. The X number went down 4. The Y number went down 3. Then I'm going to label my last point. My last point was at 4, 3. And what is its new location? 0, 0. Okay, so these are called coordinate notation. This is how things moved. That is how things moved. Okay, so whenever you slide something, this basically slid something. It didn't turn it, it didn't flip it, nothing like that. Okay, it just slid it. And actually up here for translation, I would like you to write slide a figure without turning. Okay, there's no turning. Okay, so add that part. Slide a figure without turning. No turning. Next one we're going to look at is something called a reflection. Okay, what is it? What do you think something's doing if it's reflecting things? A reflection is basically when you flip something over a line. So a reflection is a flip over a line. Okay, a flip over a line. The only kind of reflection that we're going to do is flipping over the y-axis, so that'd be side to side, or flipping over the x-axis, which would be up and down. Okay, so coordinate notation for a reflection. Okay, if you are flipping over the x-axis, your coordinate notation is going to change from x, y, and it will become x, -y. if you are flipping over the x-axis. If you are flipping something over the y-axis, your notation will go from x comma y, and it will become negative x comma y. Okay, so you'll see what this means in just a little bit once we put in some numbers. So first thing you want to do is I want to label these 3 points. Okay, these are the exact same 3 points that we just did in example number 1. Okay, so over 1, up 5, put your A point. So 1, 2, 3, 4. Label it as A. Over 5, up 5 is your B point. Remember, we always go side to side, then up and down. And over 4, up 3 is your C point. So none of these change. They're exactly the same as what we had in example 1.
Not always.
No, they're not always going to be just these same points. What I want to know is that I want you to sketch it and the image. So we sketch this. We want to sketch the image after reflection over the y-axis. So is that going to move this triangle side to side or up and down? If I flip it over the y-axis, it's going to go side to side. So if it goes side to side, are the level that it's at, like, is this A point going to move? It's going to flip over, right? So the A point is going to go from here to here. Okay, that's going to be your A prime. Where would the B prime go? If it flips over on the other side, right? So how far is it away from the X location, or from the Y axis right now? The B prime is 5 away, so you're going to go 5 away in this direction. So over 1, 2, 3, 4, 5. This is your B prime location. Then C, it's going to stay on this level, and it's going to move over 1, 2, 3, 4 away, so you're going to go 4 in the other direction. 1, 2, 3, 4. That is your C prime. Then you can connect the dots. And now I want you to label these. So X, Y turns into, since we went over the Y axis, negative X, comma Y. So my original A location was at 1, 5. What's my new A location? What point is this right here for A? Negative 1, comma 5. So if you notice, the only thing that changed is the X part became negative. Okay? Same thing should happen for B and C. Take it off. So 5, 5. What's your new B location? What point is this right here? Negative 5, 5. So when you flip over the y-axis, all that changes is your X portion becomes negative. Is it the same thing for C point?
Yeah.
4, 3. If you labeled this point, this would be negative 4, comma 3. Okay, so all that changes is just the value of the X part. Okay, it'll turn from positive to negative. I don't. Sorry, I ran out of room this morning. Okay, so that's something called a reflection. A reflection is when you flip something over a line. Okay, last thing is a rotation. Okay, if you're performing a rotation, what you're doing is turning around a point. So turning around a point.
Yeah, but scissors way.
Turning around a point. So the way you turn around a point is if you are going 90 degrees clockwise. There's 3 different types of rotations. If you're going 90 degree clockwise, it goes from X, Y, and will become negative Y, comma X. Okay, once we put numbers with these, it'll be a little bit easier. I'm sorry, I apologize. That should be positive Y, negative X. Sorry. The other way you might turn something around is 180 degrees. If you turn it 180 degrees, it goes from X, Y, and it will become negative X, negative Y. So both of them turn negative. And then the last way would be 90 degrees counterclockwise. 90 degrees counterclockwise, and in that case, you go from x, y, and this is the one that becomes negative y, positive x. So the way to draw this is, again, we're going to sketch that same triangle. So your A point is over 1, up 5. It's going to be the exact same triangle we've been working with. B point is over 5, up 5. And then your last point, your C point, is over 4, up 3. It's still going to be the exact same points. Same vertices. Now, this one says a rotation 90 degrees counterclockwise. So if you have your patty paper, you're going to want to use that. The way that we do this is you put your patty paper on here. You have to draw this cross. Okay, so draw where the XY axis is. Put a little cross there. Right here. So where the XY axis is. Then you want to label your A, B, and C points. Okay, so A, B, and C points. Then, to move this, if we're moving 90 degrees counterclockwise, is that going to be to the left or to the right? Counterclockwise moves which way? Left or right?
Right.
You would know it's to the right.
Oh, left.
Clockwise is to the right. Counterclockwise is to the left. So what you're going to do if you're going to move 90 degrees, we're going to move this cross one click. Okay, so move it over one spot. So hold it from here. Okay, put your edge of your pencil or your pen on the clock or on the cross, and it's going to turn one way. Okay, 90 degrees means turn over one place. Then from there, you're going to put your new locations. Okay, just like we did on Friday, you want to kind of punch through the patty paper. We're going to get new A, B, and C prime locations. And then once you pick them up, you can label them. So this is your A prime, this is your B prime, and this is your C prime.
What are you talking about?
So on this last one, if we're going to write our A to B, or our notation, okay, the way we do that is your first point was over 1, up 5. What is your new A location? -5, up 1. So this turns to be -5, up 1. What is my new B location?
-5 up 5.
-5, up 5. And what's my new C location?
That's fantastic.
-3 plus 4.
-3, up 4. That's what that looks like. So for the next couple weeks, we're going to be working on all these different types of transformations, okay? Translations, remember, is when you slide something. Reflection is when you flip it over a line. And rotation is when you turn something around a point. The way that this foldable works is if you turn your paper sideways, these fold in. So fold these inside to that black line. And then fold this one inside to the black line. And then you can take scissors and cut across, or cut along those dotted lines. Huh? Stop. Okay. The way these go is then if you opened up each part, translation, that's a translation. Okay, so you could open up each part.
How did you do that?
Okay, take your paper.
Put it to the line.
How
did you not do that?
turn inside. So, okay, turn it over. So like this, fold it in, and fold it in.
You didn't.
Then you cut along the lines, cut along the dotted lines, and then you have your foldable.
Oh,
This does need to be put into your notebook